Hey everyone, and welcome. So today, we're going to pull back the curtain on a feature in Python that honestly feels a little bit like magic. It's called operator overloading, and it's the secret to teaching normal operators, like the plus sign, how to work with the custom objects we create. And let me tell you, it leads to some incredibly clean and intuitive code. All right, to really get a feel for this, let's start with a little puzzle. This question really gets to the heart of what makes Python so cool and flexible. Okay, just imagine for a second you've made your own point class, with an x and a y coordinate. Now, if you create two of these points, say p1 and p2, and you just write p1 plus p2, what's supposed to happen? How on earth does Python know what adding 2 points even means, right? It's not a number, it's not a string, so what's the deal? Well, the answer to that little puzzle is a really powerful concept, and it's exactly what we're going to break down today. It's called operator overloading.
And you know what? The core idea is actually super straightforward. Operator overloading is all about giving us, the developers, the power to write the rulebook. We get to tell Python exactly what to do when it sees a plus sign or a minus sign used with our own custom objects.
And here's why that's a huge deal. It basically lets us bridge the gap between our own custom-made classes and Python's built-in types. We can make our objects feel native. You can add them, compare them, check their length, just like you would with integers or lists.
Okay, so how does Python actually pull this off? It's not really magic, of course. It's actually a super clever and consistent system. So let's pull back the curtain and see the secret sauce.
So, you're in your code. You type something that just feels right, like x plus y. What is actually happening under the hood?
Well, what's happening is that Python is secretly translating that simple plus sign into a method call on that first object. It's calling x._add_ of y. These special methods, the ones with the double underscores, which you'll often hear called dunder methods, they are the real engine running the whole show. And this pattern holds true for so many common operations. You use a plus sign, Python calls _add. You use the len function, it calls _len. You check if x is less than y, it's calling _lt. And when you check for equality with a double equal sign, it's calling _eq. You see, once you get this pattern, the magic kind of disappears, and what's left is a really clear, predictable system. Now, don't think this is just for doing math. This whole concept goes way beyond that. You can use it to make your objects behave in all sorts of cool and intuitive ways. So first up, you've got the ones for making your objects act like numbers, which is what we've been talking about. You can define what addition, subtraction, multiplication, and division mean. This is absolutely perfect if you're building classes for things like vectors, or matrices, or even complex numbers.
But check this out. You can also make your objects act like containers, like lists or dictionaries. If you implement a _len method, boom, your object suddenly works with the len function. Add an iter method, and now you can loop over it with a for loop. It's incredible. And with _contains, you can use the in keyword just to see if something is inside your object.
And then, of course, you can define your own rules for comparisons and for how your object looks when you print it. You can tell Python exactly what it means for one of your objects to be less than or equal to another. And that _and_str method? Oh man, that one is so important. It controls what you see when you print your object, which makes debugging your code a million times easier. So, okay, we've seen all these dunder methods, all this behind-the-scenes stuff. The big question is, why? Why does any of this really matter? What's the actual payoff for us as developers?
The source material for this explainer really nails it. It says the whole point is to make classes work more like fundamental types. Think about that. It's all about making the things we build feel just as natural to use as the language's own building blocks, like integers and strings.
So, at the end of the day, operator overloading isn't just some clever party trick. It's a fundamental tool for writing better code. It's about making your code more expressive, more elegant, and just plain easier for other people, or even your future self to understand. When someone can look at vector1 plus vector2 and know exactly what's happening without digging through your docs, that's when you know you've written good Pythonic code. So there you have it. You know the secret now. It's not magic at all. It's just a really well-designed system of these special methods that puts all the power in your hands, the hands of the developer. And that really just leaves us with one final, exciting question. Now that you know how this magic works, what are you going to build with it?